So section 2.5 is about the power rule. My goal for you is to calculate the derivatives of some common functions. Before I show you what the power rule is, I'm going to give you some examples of it, and maybe you'll be able to kind of figure out in your brain what it is. And the purpose of the power rule is to make derivatives easier. If you don't have the power rule, then you're going to be having to use limits to calculate derivatives, and that can be painful and take a lot of algebra. All right, so I'm going to just show you some examples. I wouldn't write these. I'm just going to show you some examples. So f of x equals x to the fourth. F prime equals 4x cubed. What do you notice? What do you wonder about the relationship between those two functions? I want to really emphasize that graphically, x to the fourth is a function that begins with a downhill slope, and the slope gets less steep and then flattens out, and then x to the fourth has an uphill slope. And what we notice about f prime is that f prime starts out negative, has a slope of 0, it has a value of 0, and then has positive values. So I haven't proven anything, but that's a support for my claim that those two functions are f and f prime. All right, f of x equals x to the third. F prime equals 3x squared. Here's a picture of that. X cubed is a function that starts out, that is uphill, and then flat, and then uphill again. F prime is a function that starts out with positive y coordinates, and then 0 y coordinate, and then some more positive y coordinates. So that's some support that those two functions have that relationship. Here's one more, x to the 1/2. F prime is 1/2 x to the negative 1/2. Here's a picture of that to kind of support it. X to the 1/2, the square root function, starts out very, very steep and uphill, very steep, and then flattens, it levels out, so becomes less steep. And we can see it's still positive, though it doesn't ever get negative. So if I look at the f prime that I have, starts out very, very high, and then stays above the x-axis, but the y-coordinates get smaller, just as the slopes of f get less steep. Here is the power rule then. The power rule says that if your function is x to the n, then the derivative of your function would be n times x to the n minus 1. You decrease your exponent by 1, and you bring it down in front as well. I'm going to give you some examples. I would actually recommend pausing the video and making sure that you're comfortable with the power rule before you move on. Here's some extra tips. Make sure you rewrite it so it looks like x to the n before you start taking the derivative. So h is fine, you can start right away, but f and g, you're going to want to rewrite those. Then you're going to apply the power rule, and then if necessary, you're going to rewrite it again. So pause here, try these derivatives, and then unpause when you're ready to discuss. So the first one, h prime equals 5x to the fourth. If you got that, thumbs up, nice job. The second one you're going to want to rewrite. Before you start taking a derivative, you'd want to rewrite that as x to the 1/3 power, because that's how fractional exponents work. And then you could take a derivative. You get 1/3 x to the negative 2/3. And if you want to be fancy and rewrite it so it still looks like a root, that would be 1 over the cube root of x squared. You don't always have to do that, but it's sometimes a good practice to know that you could do it if you had to. And then g of x, be really careful of these ones. Make sure you rewrite before you do that. That's x to the negative 2. And now you take a derivative, and so that would be negative 2 x to the negative third. And that looks even better if you rewrite it so it's negative 2 over x cubed. Now, just a word of warning, you can't use the power rule if it doesn't look like x to the n, which is why we had to rewrite f and g before we did the power rule. Right? Here's an example of how much time this can save you. In the old days, if we wanted to write the equation for this tangent line, we'd first have to find the derivative, and we'd do a limit as h goes to 0 of f of x. So this is how we would have done it. Oops. This is how we would have done it in the old days. We would have done the limit as h goes to 0 of negative 2 plus h cubed minus negative 2 cubed all over h, and then we would have gone through that work. But this is equal to f prime at negative 2. So we can save ourselves some time by just taking f prime using our new shortcut. So f prime is going to be 3x squared. And so that means that f prime at negative 2 would be 3 times 4, which is 12. Just to be very clear about the way order of operations works, this would be 3 times 4, so that would be 12. And so that means that we have our slope of 12. And if I have the x-coordinate is negative 2, so the y-coordinate is going to be f of negative 2, which would be negative 2 cubed. So now I have the three things I need, the x-coordinate, the y-coordinate, and the slope. So the equation for the tangent line is going to be y equals 12 times x plus 2 minus 8. Remember, you can stop there unless somebody tells you you have to do more work than that, or if it's multiple choice and you have to match a multiple choice answer. All right, this is the power rule. It's a powerful derivative shortcut.